communication last two classes, why modulation we have to do, especially while transmitting wirelessly, the antenna size, relationship between the frequency of the carrier and also the antenna length. Also, we saw this one. Then we have talked about wireless on three type widely used. One is Zigbee, Bluetooth, and also Wi-Fi. We started with Zigbee communication. Quickly, I will just go through that. It is uh, developed by Zigbee Alliance, which works on ISM band. This is carrier frequency. The 2.4 gigahertz the transmission frequency. It uses 1 megabit bandwidth. It is a wireless personal area network. It is very short range only. We know that it can go generally up to 30 meter, maybe little extended, but officially this is allowed. It is a low power communication because the what do you call a range, correct? Range is distance between the transmitter receiver is maximum 30 meters. So in that case, you need not have the kilowatts of power or this one. It is generally about milliwatts or watts, low power, operated with battery, because it is used for transmitting data between nodes for wireless sensor technology or autonomous vehicle, all these things, where the between the transmission has data can happen within few meters, few tens of meters. Okay, so high power is not needed, battery operated, so you should not transmit huge power, then battery will drain quickly. Then low data rate, transmission rates go up to 250 kilobits per second. Correct. This is very low compared to CAN bus 1 megabits. Correct. It can go to 8 megabits CAN FD. But if we go to the FluxRay or most, or there we go up to megabytes, 150 megabytes, 500 megabits, very high transmission because the data transmitter is this one. So this is used for maximum 250 kilobits. Transfer rate is in fact, it's lower than what we are going to other wireless network, Wi-Fi. Correct? We are going to see. And it can have up to 1,000 nodes in the vicinity. It uses 16-bit address. Okay. This is what we talked about previous class. Then we altered because it forms what you call network-based communication, wirelessly connected network, as Zigbee network. Already we know that there are three types of elements in a network, wireless network, given network. Definitely, there has to be a coordinator, Zigbee coordinator for this given network, and it may have routers. Routers generally collect data from the end devices, which you call end devices. End devices, router, and coordinator. There can be only one coordinator, but it can have many routers and many end devices. To end devices only, actual sensors are which is going to transmit data from sensor or some ECU, whatever it may be. Data is coming only from the end device. Routers are intermediate device which collect the data from the end devices like this green one. And please see that this is going to collect from these two devices. That will be sent to one more router from which it goes to coordinator. From coordinator it goes to network, outside world, correct? Through internet also, wherever it may be. So this forms the internet network. Already we defined what are the job of each of the this one, three types of, correct? Zigbee coordinator, what is tasks of a coordinator. Then we also the router, it is intermediate device. It passes data received from other end devices or end nodes and also from the other routers, correct? This end device sends to this router. This in turn go to another router. Finally, this go to coordinator. Please note, take this network because you are expected to draw this, correct? Functional block diagram of your Zigbee network means you are supposed to draw this. Correct. Hand sketch is sufficient, but you are supposed to do. And we will also talk what is the function of each this one type: coordinator, router, and this one. Okay. I am not going to repeat. Now we know that the Zigbee is a network device. The network can be different topologies. Correct. In the network topology, there are different types. One correct. It is a combination because generally there are two types that are very popular. One is called star topology, other one is mesh topology. Okay, so this is called star topology, correct? Generally, if you are asked to draw in your school a star, what you will do? You put this one, put like this, sun, all these things, right? So these are you represent. So that's why it is called a star topology. This is a starlight coming out, correct, in all direction. So this is a star. So if I connect my Zigbee nodes, center one is, for example, this is my router. correct? This is my router, and this is end device, ED1, ED2, correct? This is ED3, ED4, or ED5. From here, this is router. Actually, these are end devices. This in turn goes to coordinator. From coordinator, go to outside world. Correct. So please see the data is coming from different end device collected by the router. Router in turn sends to the coordinator, which send to internet. Correct. So this kind of network called star topology. Correct. So this you can see that this is star. You can have many numbers. It's not the only 5. There's a center. Router is in center. End devices are connected to the center. Correct, to the router. Data flow is like this. This is called a star topology. Okay. Then other one is called mesh topology. In mesh topology, you can see that. Please see that as we told that in the Zigbee topology, network, we should definitely need a coordinator. Correct. We may need router, but definitely there will be end devices. Here, these are end devices. ED1, end device 1, ED2, correct? ED3, ED4, and ED5, and there's no router. All these are connected directly to my coordinator. Coordinator shown as red color, right? So the data is collected. This is in turn is connected to the computer, main computer, which is connected to outside world, right? Output. So now this is called star topology. In mesh topology, you can see that there are Zigbee routers. Blue ones are the Zigbee router. Please, blue ones are the Zigbee router. In your network, there can be only one coordinator. There's a coordinator. They call mesh configuration. Right? In mesh configuration, you can see that many routers are there. They're all interconnected. Right? And finally, this is connected to the coordinator. Coordinator in turn is connected to the outside world through a computer or whatever. This is outside world. Right? Output or outside world. So these are the end devices. Yellow ones are end devices. Okay, if you connect the end devices, routers, and coordinate like this, it's called mesh topology. Right? We have just shown there are 5 routers and 7 end devices, 1 coordinator. In network, there is only 1 coordinator. So this is called as mesh. This is called a star. Then sometimes you can have another type which is called clustered tree. Correct? The third type is called clustered tree. Apart from star and mesh, this is another type they call it. You can see that it is like a tree. Correct? When you say a tree, value to draw, correct, which is called that is stick diagram. How will you draw this one tree? Right? So these are branches. Correct? This is main trunk, another branch, sub branch, like this is correct. So this is called as a tree topography. Correct? So tree represent main trunk, yeah, main 2 branches from which there are sub branches. Then finally terminate. This is what you draw as a tree. Correct? If you want to show it as a sketch, line sketch, we call it simplified. Correct? People understand. This is a tree symbolically. So now you can see that this is there's a main thing going out to a computer, right? So this is my coordinator. Coordinator connected to 3 routers, blue ones, which in turn have branches. Correct? So this is one star topology. This is another star topology. This is another. Together, this is star topology. Correct? If you connect like this, it is called cluster tree or tree topology. Correct? Star, mesh, or tree topology. These are 3 different type of use for connecting various Zigbee devices or nodes and forming together. Whole thing is called as a network. Right? This is one network. This is another network. This is another network. Okay. So now another thing is there. We want to talk about it. Combination of star and mesh topology is also possible. Right? You can have star, mesh, or a tree, or combination of this and this. Right? What I am saying is, so so this can become one more node. Okay. This is also note. This can be connected like this. Correct? This is a combination of both. A star is there, a mesh is there, but please see that together is one combination. And this is the output. One coordinator. There are 5: router 1, router 2, router 3, router 4, router 5, router 6. This forms a mesh topology. This forms a sum, but together we connected like this, so it become a the combination possible, right? So this is also possible. That depends upon where you need. So there are two type of this one devices in Zigbee topology. One is called full functionality device. Other one is a reduced functional device. FFD, RFD. Okay. So for example, here there's a Zigbee network is shown. Correct. A Zigbee network is shown. Again, please see there's only one corner here. In this case, shown as a green color. Blue colors are called as a routers. The yellow small dot is called Zigbee end devices. Okay, you can see that they are all connected together. This is an example for Zigbee network, wireless network. Now, okay. Now, how the Zigbee topology works, we'll see. Correct? Zigbee protocol. Okay. In Zigbee, it is the layered architecture. Correct? There are layered architecture. Generally, there's a ISO 7-layer architecture. You'll see that already we saw 7-layer architecture. Where did we see? Any idea? We talked about 7-layer architecture in previous classes.
In
wired communication. CAN bus, yes. Similar to that, you can see that physical layer, the actual circuit, IC through which wires, ICs, all those things. Transmitter, receiver. This is hardware. Right? So remaining whole thing is software modules. There are 7 layers. You can see that. So this is the application software. Correct? Then application. Then you have Zigbee device object. You have to create object. Correct? It is like forming a frame. Correct? So the data is available. Data is coming from the application layer that cannot be just transmitted. Who is going to transmit? This physical layer. This is the Zigbee transmitter hardware. Correct? This is a hardware. Correct? The last layer. So the data, first it has to be, we know that in CAN bus also, LIN bus also, data is coming from your program. Correct? ECU. That will be added with start bit, end bit, parity bit. In case of RS-232, if we talk about CAN bus, you have a startup frame, then a number of bytes you are going to transmit, then you have the actual data, then CRC code, stop bit, all these things are together, you call the CAN frame. Similarly, in your LIN frame, you have a header. Header is sent by the transmitter or the LIN master. The slaves will respond with the data. So together called a LIN frame. Similar to that, here also, finally, your data is that is called as Zigbee object. Correct? ZDO. Correct? Zigbee device object. It is nothing but you can consider similar to a frame. Everywhere you can then from the once the frame is formed, then subsequently you have other things. Correct? Network layer, medium access layer. Please note that all these things are implemented as software modules. When you are going to implement Zigbee, you will from the data is coming from this one, and after that you do the Zigbee object you have to create. After that you have to application layer, correct, address, all those things should be finally to be transmitted by the physical layer, actual transmitter hardware. Wirelessly data will be transmitted. No physical connection, wireless, right? Data is transmitted. Sorry. Please see what is the job of each layer. It is a 7-layer architecture. The lowest is physical layer. Physical layer does the modulation, demodulation, transmitting, receiving signal. Right? Actual hardware is this. This is what this. You have the antenna, correct? This is the Zigbee transmitter, receiver, modulator, demodulator. Everything is available in this hardware, in which you are going to put the remaining 6 layers. Right? 6 layers of this one as a software. That's what is mentioned here. So the MAC layer, the next from this one, the MAC layer, next immediately above this one. Please note that all these things are software. Okay, responsible, reliable transfer data by access different networks with the carrier sense with the CSMA. Do you remember what is CSMA CD? In Canvas, do you know the arbitration resolving? Transmit first bit, correct? We call it as correct. Carrier sense multiple collision avoidance. Similar to that. Here we are going to do wirelessly. There it is a wired communication. That is done by MAC layer. Also transmits beacon frames for synchronizing communication. Again, I told you there are frames. In here also, data is not just sent. It has to start to stop like that. There are many things are there. All these things are together. And the Zigbee protocol, the first frame sent is called beacon frame. Data will never send immediately. Wirelessly, this Zigbee node will not transmit just like that. Right? First, it send a beacon frame so that neighboring Zigbee nodes will automatically get connected, synchronized. After that, data will be transmitted. This beacon frame is similar to start, correct? So first data will be transmitted. First is a beacon frame will be transmitted. Who is going to do all this? The responsibility of the create the beacon frame, all this thing, job of the MAC layer software, correct? The network layer takes the care of network related activity, setting up end device, connecting, disconnecting, correct? We know that now we take this this one, correct? Suddenly this router failed, correct? Hardware. Please know that each the circle, whether it is a router or a coordinator end device, is nothing but this device. This is one node, correct? This node can function as a coordinator or a router or a end device. End device means sensor will be collected. Router means it may connected to another router, or it may be connected to one end device or two end devices. Data will be collected. Then it goes to coordinator. So now what? Suppose this. Now, for example, this is the data has to go. This device, I say the end device ED1, correct? It is connected to, for example, temperature sensor. The data, what it will do? Data will be collected, sent to the first router one, R1. I call R1. R1 can send the data where it has to go. Finally, it has to go here, right? Let me give you this one path. From the end device, it has to go to router, through another router. Actually, finally, it has to go to coordinator. From coordinator, it has to go to outside world, right? Outside world, it has to go. That means from here, data originates, goes to the router. Router is connected to this router. Please note that if you see here, this router is connected to 3 more routers. This I call R1, this is R2, the R3, R4, R5. This is coordinator C1. For example, this is D1, device 1, device 2, device 3, device 4, device 5, device 6, device 7. Okay. Now, all the devices data will go like this. Outside world. Only way is going out through only the coordinator, only one coordinator. So from this device D6 can send data to this only, because this is connected to the R5 only. D6 is connected to R5. That means data it cannot go here because there is no connection. Wirelessly also not connected, not the physical, wirelessly also it is not connected. Data transmits through wireless, but now this device, the D6 is connected to R5 only. While they call configuring. Okay, it is not connected to this device, right? So this is R6. Sorry, this is called R4. Okay, now data from here go here. From R5, where it has to go, data should go to C1. It can go directly like this. Otherwise, from here it can go here to R3. From R3 it can go here. Otherwise, it can go to this device, that is R4. From R4, R3, again go to R2, then go like this. You see the multiple paths. What is the advantage of mesh configuration? That from the one end device, correct? It is connected. There are multiple paths. There are 3, 4 paths. If one device is failed, still you can transmit data. The entire network will not collapse. Mesh configue advantage is the entire network will not collapse. Even one router fail, you can transmit data through other routers. Correct? From here it go directly. If correct? Now if it can go like this and go like this, then go like this, or it can go like this, go like this, go like this, come here, go like this. Multiple paths are there. Now, some device fail, you can send in alternate path, right? From here, it can go like this and go like this. Suppose this device fail, still from here, you go and send it to his alternate. That is advantage of mesh configuration. Correct? You want to see that there is at least one alternate path is available. Correct? In star, sometimes not possible. Correct? So now, for example, take a star configuration. The tree or the star. This is a single star. This is multiple star. That is T configuration. This device is transmitting data. From here, it has to go here, then goes to outside world. Okay. Now, if this fails, these two nodes are gone because they are connected to outside coordinator only through this router. If this router fails, means these two devices, even though they are not, data can be transmitted. That is disadvantage of star configuration. Correct? Mesh means one fails, or you can send possibility of that sent to other devices. That's what we are talking. Note the advantage of mesh and star configuration. Right? Mesh has advantage compared to star. But many times you have unnecessarily redundant additional nodes. Correct? This is not needed. Correct? Literally speaking, this is not needed. I can, because from here, these two are connected here. Correct? From here, these three are connected to this. From here, directly goes. From here, at least one is sufficient. These two you can avoid. Correct? With a mark. So these two are additional. You are increasing cost in mesh node. You are putting additional nodes. Cost increases. But advantage is redundancy is possible. Correct? So some advantage, some disadvantage. What is the difference between mesh and star? Note down these points. In the exam, you can, because it is all expected. Okay. So network layer takes care of network layer setting up device connection, disconnection to device, routing, correct? Routing, all these things, who is going to do? Network layer of the software. Then finally, application software sub layer, correct? This is sub layer. What is job? Enable service device and SFR device to object and application objects to interface with the object means the data what you are doing. You can think similar to a frame, correct? That is called software object, they call it, not a physical object. Software object is nothing but actual data. You'll add some bits, CRC bits, all those things. That's what is created by this, correct? Application layer only where data is created, actual data what you want to transmit. From here it comes here, from here it comes here, comes here, comes here, finally goes out. This is the path. Each layer goes, finally goes out. This is output, right? Data is transmitted, generated in the application layer. Then application framework. So now we can see what is each layer job. Interface network layer for managing data, that is done by this. Then application framework. This is the application framework which provide two types of data. Sorry, one is called key pair and generic messages, right? And generic message defined by structure, whereas key values pair is used for getting attributes. Just remember this, what each one is said, correct? What is the job? ZDO provide. What is ZDO? Is nothing but Zigbee device object, which actually contains your data. Data created here, that is packed inside the ZDO software or similar to a frame, that is sent to next layer. Each layer is adding something. Please remember start bit, stop bit, CRC, like that. Each layer has some work. Okay, finally data is transmitted. Data is transferred in packets. Please know that data is sent as a packet, not continuous one. Similar to a frame. In CAN bus, LIN bus, we call it frame. Here it is called a packet. Correct? Packet is nothing but you can consider similar to a frame. What is the maximum size of data in your packet? 128 bytes. That means 128 into 8 bits. So many bits. That is maximum possible in Zigbee. At a time, you can send only 128 bytes of data or into 8 bits. So many. Whatever CAN bus, 64 bytes. or 64 into 8 bits. That is maximum in a frame. Can.
That is
Right?
for can 2 be, sir. For
Yeah.
one, it is only 8 byte if I'm not wrong.
Yes. This 64 in 2B to 2A, it is only 8 bytes, 64 bits. Here, this one. Okay. But in this case, you can go up to 128 bytes if possible. Please note that here wirelessly transmitted. This is a wireless communication. Again, data is sent as a packets. Okay. Packet will have similar to error checking code, star, all this thing. That's what is this. Whole thing talks about it. Can I go to the next slide? You can take what are 7 layers, correct? Zigbee protocol architecture means 7 layers. I'm not going to, you can draw application framework, correct? From there, it comes to application support. The 7 layer names and approximately what they do. That's what I'm explaining. Another one more thing, please note down. The packet size is 128 bytes, but actual data 104 bytes only. What about remaining 24 bytes? That is meant for start frame, all these things, other information, CRC, something like that. That's what they say. Maximum size of your packet can be 128 bytes, in which data is only 104 bytes. Actual data. You add CRC or error checking, all these things, together you build a single packet. The packet can be considered as a frame. In case of CAN or LIN, wired coming here, they call it a frame. Application layer jobs, what are the important points? Everything is mentioned. Each layer does some. Each layer. Please know that all these things implements are software layers. If you start working on it, you will understand. We are giving introduction how it works. Okay. So where the Zigbee is used, application, industrial automation, wherever you want wireless communication, you can use it. Okay. Home automation, smart metering, correct? Energy consumption, electricity power consumption, all those things, correct? So what you can do is, you know that your electricity meter, in government is also planning. See, each area in your street or in your locality, correct? There will be a where you go on to a substation, correct? Where the electrical power comes from the main this one. There will be a transformer, there will be office, correct? Electricity board office will be there, correct? There where you go and pay the money, all those things. Now you are doing manually, correct? Electricity meter, somebody comes and collects the meter reading monthly once, all those things. Smarter meter means it will turn automatically through wire. Future they want to use this for wireless communication, Bluetooth, right? Or Zigbee. So there will be a main this one this on the EB office. Each home you have this one meter. That meter will be Bluetooth enabled, the Zigbee enabled. So whenever the meter reading is needed, the electricity office they can wirelessly connect with your meter, collect the data. Right? So smart metering, including energy consumption, price support, something, home automation, lighting configuration, appliance, correct? Starting your microwave and fridge, all these things, heating, cooling system, AC, all these things can be connected. And of course, industrial automation, correct? Communicate, can monitor various parameter, monitoring various parameter automation, equipment. Main advantage is it is highly flexible. Wire is not needed, correct? So the wire is there, somebody digs. For example, telephone cable. You would have seen old generation, correct? Yeah, telephone cable will be there. Some road construction worker, they'll come and dig with this one. They cut the cable. Over. Your phone work for 1 month. Again, they have to relay all these things. Now, cell phone, nothing. Right? You with your cell phone, anywhere in the world you can talk. Right? Suddenly, today you are here, take a flight, you go to US, 12,000 kilometers. Again, you can talk. Still, you are connected. correct? Same thing only wireless communication, any wireless communication advantage, smart grid operation, finally autonomous vehicle, right? Where definitely you need this. Moving object, you cannot put wired communication. So you need wireless communication. These are the, I gave some 5 examples. Wherever you want wireless data, you can use this. Short range communication. Okay. Here, one company, Libilium, correct? One company, correct? I took from internet. The vehicle tracking, correct? Logistic tracking, vehicle tracking. So they want to use Bluetooth. This picture took it from the website, correct? Vehicle tracking, tracking and monitoring using Zigbee. This is a company which developed the software. I think it is a European company, Netherlands or something. You can see that each device is with a Zigbee. This means Zigbee transmitter is there, correct? That transmitter connected to ECU, correct? For example, your vehicle position, correct? Or engines, whatever. So these are transmitting data to this one, Zigbee. From here, it comes here. All the devices are transmitting wirelessly data, right? Or it can transmit to this also, right? On roadside, they will install the Zigbee receiver, router. These are routers, correct? Which is installed on roadside. And the Zigbee transmitter, that is the end device, ED1, ED2, ED3. Each vehicle has then one Zigbee. They're transmitting data. Automatically, as the vehicle comes, it will get the nearest Zigbee router. These are router 1, router 2. Sorry, this is router 2. This is router 3. Correct? So, as the vehicle is coming, it will connect the nearest router and it will go. Now we can see here. Now, this is your coordinator. Right? This is router 1. This is router 2. Correct? This is ED1, end user device 1, end user device 2, ED3, ED4. Right? You can see that this device connected to this device also get connected. This comes here. From here it goes out. Correct? The dearest one. So this device is connected to this also connected. Please note that if range is sufficient, this can connect here also. Initially it was connected here. When this vehicle was here, it was connected here. When it moved away from the range, I told you it is only 30 to 40 meters. When the vehicle moved it, automatically it will get connected. Correct? That is advantage. Correct? Wireless coming advantage. Automatically, as the vehicle is moving from one location, it connected nearest router. From router, it goes to the nearest coordinator transmitted. Okay? So that's what they see. So you can see that between these two, the range may be 30 meters. This device connected here. Initially, it was connected here. Please, that's what they are saying. Initially, at time T0 equal connected here because this is the nearest router, Zigbee. It was moving, correct? After moving this much distance, the distance is too much, so automatically just connected here after T2 seconds. Correct? So this how you can see here. This is they developed. It is a commercial company. They are selling for logistical company, right, where they want to tracking the vehicles, all those things. Okay. Bluetooth communication system, wireless technology, standard for exchange data between fixed and mobile devices or mobile to mobile for a short range. Note on important bulleted points. Using short wavelength UHF radio wave, that is 2.4 gigahertz. Okay. So this is called, I already told you, it is called ISM band. What is ISM means? No doubt, industrial, scientific and medical radio band. This frequency 2.4 gigahertz to 2. This you can see that 2.4 to 2.85 gigahertz. That is the band allotted for ISM. Somebody said, what is ISM? It is nothing but industrial automation, scientific device connections, or medical devices. All these devices, if you want to use this one, Bluetooth, you can use this. Now, this is Zigbee over. Right? I told we are going to talk about 3 type of devices. One is Zigbee, we completed. Correct? This is next device, Bluetooth communication, another short-range communication. Correct? Again, it also is ISM only. Please see here what we do. if you remember correctly, ISM band. Zigbee also uses ISM band only. What is the band? 2.4 to 2.85 gigahertz. That is sufficient. That band only you have to use for Zigbee communication. Bluetooth, you have to use only this frequency for broadcasting, like a carrier frequency. Correct? A band. Okay, so Zigbee is also using ISM. Bluetooth also uses ISM only. Right? The range is this note down 2.4 to 2.85. That is nothing but 850 megahertz. That is band available. A band. Huge. 850 megahertz, huge band. Okay. This is used for personal network. Personal network within the building, you know. For example, if medical, you go to, for example, Apollo Hospital, correct? Big hospital. Now, yeah, ICU is there, correct? Heart rate monitor, correct? Pulse, this are the sugar level, correct? And the oxygen level in blood. There are many devices, small devices. Now, in your hospital, there may be 100 ICUs, correct? 100 patients are there. Now, the data should be monitored by a staff nurse. One floor, big, go to big hospital, you would have seen, right? Many ICUs, there'll be heart rate monitor, ECG, all many devices are there, many sensors. They're all connected to your wires. Then the data should go to a doctor or a chief staff nurse sitting in one room where she has to monitor. So for 250 beds, if wired, till now we are using wired network only, correct? RS-232, RS-422, CAN bus, something like that. Now they started using Bluetooth, correct? Bluetooth means no wires, correct? All the devices will be connected to main this one. So Bluetooth they use for monitoring, bedside monitoring, all these things. That's what I am talking, right? So why the name Bluetooth? This was invented in Denmark. Denmark, right? This was invented in Denmark. This type Bluetooth was invented in Denmark. So to honor the king, those scientists, his Danish king Harald Bluetooth. His name, the king name was Harald Bluetooth. To honor him, they said Bluetooth. That's how the name came. Of course, now everybody is using. Initially, they want, like if you see Britishers have lasted for 1,000 years, anything with they put the king name, queen name, something. Many of the invention also, they give the name to honor the king. City name, correct? British people went and USA, correct? North America. Some 400 years they were colony, correct? You will see that all the US city name, equivalent name will be in Europe, correct? All the European city name as a name because these people went from Berlin, correct? London, this one, Glasgow, correct? Or Stockholm, something. When migrated, because they have the fond memory of the native, the new village, what they're farming, they put the name or the king name, correct? Like that, these people also did. Okay, fine, that is next. Okay, now in North America, industrial scientific ISM band wave is divided into 79 hopping channels. I told you the band, we say that x-axis is the frequency, say 2.4 gigahertz to 2.485 gigahertz. This is nothing but 850 megahertz the total band. This is divided into 79 channels. Correct? 850 divided by 79. That means per channel. Correct? You make it round number easy. I will make it 79 is there, but understand why I said the 85. Correct? Each channel will have 85 means 10 megahertz will be the band. Per channel, approximately 10. But please know that the 850 divided by 79. For understanding, I told you. So each channel has a bandwidth of 10 megahertz. Total band available. Okay. Again, one more thing also, the power that can be transmitted by a Bluetooth device maximum is only 1 watt. You cannot transmit with Bluetooth device 10 kilowatt or 1 kilowatt, 100 watts. No. Why? This has to be the device can transmit only up to 40 meter, 50 meter short range communication. Otherwise, this will go and disturb other communication. Police, all those things can interference. So this should be used only vehicle to vehicle communication within short distance. All the Bluetooth, all this thing only low power communication, short range only. That's the range is decided. Here it cannot exceed. This is a rule made by. If you make a Bluetooth device, the device power cannot be more than 1 watt. That means 1 watt is sufficient to reach next Bluetooth device, which is 40 meter, 50 meter away. Okay. With 160 frequency hops per second. We'll see what is the frequency hops in next. It was originally conceived as a wireless alternative to RS-232. Correct? Even before CAN bus, the Bluetooth that come in Denmark, medical devices, Danish company, Denmark companies are making in Europe. Correct? So they want to have wireless instead of wired communication. RS-232. We know that RS-232 19.6 kilobit by bytes per second. Kilobits per second, slow speed. For an alternate to that, they developed this Bluetooth in Denmark. Okay, Bluetooth is managed by now. Even though it was created initially in Denmark, Danish scientists, now it become a worldwide phenomenon internationally. Everybody is using. As I told you, it is used for vehicle company, medical devices, all these things. So now it is controlled by one group of Bluetooth Special Interest Group, SIG. We saw that previous one also, Zigbee also. Zigbee Association was there, where the automobile company, correct? Now today, tomorrow you start account, you can also become a member. If you want to use this one, you have to become a member, pay some royalty, something like that, or some permission. So you can do it. More than 30,000 companies. Because I prepared this slide some 4 years before when I started teaching this course for this one. That time 30,000 company, I got it from internet. Right? This course I introduced for VMAX students. Now I am teaching, I told you, other students also, 60 students, 70 days, because many students are getting jobs in automobile companies. Right? Starting from BMW, Toyota. One student who did a course with me, dual degree student, he got job in Toyota, Japan. Previous year, one fellow did same course. He also went and attended Toyota, now he's in Japan. Correct? So regular students are getting. I am saying that this course is really useful to many of you. So that time with this one, now it is with it. Then it became a IEEE standard. Correct? Basically started with one company. Just 1 minute. Hello. சொல்லுங்க. அந்த இது என்ட்ரி பண்ண கோட் என்ட்ரி பண்றதுக்கு இந்த இது ஆமா கிரேட் ஷீட்ல ஆமா இல்ல அவங்க ஏதோ திருப்பி பேசணும், அது கூட பேசுங்க. ஓகே. Now I'm in a class. Can I ask her to call me tomorrow daytime? Because now I'm in the VMAT class, online class going up to 7 o'clock. நாளைக்கு காலையில் கூப்பிட்டு சொல்லுங்களேன். இப்போ நான் கிளாஸ் இருக்கேன், பிட்வீன் த பேஸ்ட். ஓகே. It became a, sorry, there's a call from VMAT office. I have to answer. Okay. So it is become a international ISO, there's an international standard, IEEE standard. The standard number is IEEE 802.15.0. This is for Bluetooth. If you see this IEEE standard, you know the automatically Bluetooth device, right? Okay. But this was standard they given, but they're not maintaining, it seems. But Bluetooth SIG, the special interest group. Bluetooth special interest group is the 30,000, 50,000, 40,000 members are there, like a consortium. They are controlling this, right? So Bluetooth SIG was the development, specification manages all these things. That means if you, for example, tomorrow you want to develop a Bluetooth device, right? your company was starting and you want to develop. So if you want to use Bluetooth, you have to contact the SIG group only. They will give permission, all this thing you have to do. That's what we are trying to say. Bluetooth device must be, your device must be Bluetooth SIG standard to market as a Bluetooth. That's what I told you. Main thing. That means you have to contact this group, get their permission. Then they give the specification. I told you it has to use only 2.4 gigahertz, that frequency band. Power should be only 1 watt. All these things, correct? What type of technical specification you have to talk to them. Sorry. So Bluetooth is a packet-based protocol which uses a master-slave communication architecture, right? We saw the LIN bus also master-slave, similar to that is wired communication. Here is wireless communication. Okay. So in your Bluetooth, this one master may communicate with up to 7 slaves, right? Correct. We saw that in the case of previous Zigbee, up to 1,000 devices can be connected as a Zigbee network. Correct. In this case, only maximum 7 devices. In your one group network, one master with 7 slaves. That is called a pico net. Pico means small. Correct. 10 power minus 6 is micro. 10 power minus is called nano. Correct. 10 power minus 12 called pico. Correct. For example, cell phone, 1 lakh cell phone can be, or 10 lakh cell phone, very big network. All are connected. Compared to that, here only 7 devices can be connected. That's why this is too small. I'm just giving you this, not exact reason, like the small network, only 7 devices connected. If you go to Zigbee, up to 1,000, compared to 1,000, 7 is very, very small, right? 7 devices. But here, one network can have only 7 devices. There should be one master, remaining can be slave. All devices must share a clock. Because master will generate a clock. That clock should be shared, will be used by all the slaves for synchronizing purpose. Even in the wireless, there's a synchronization there. Master generates a clock that will be shared to all the slave devices. Again, this also works on packet. Correct? Packet by packet only, this is going to transmit. So the packet exchange is based on basic clock defined by master. Then another unit is called apart of what you call tick. Correct? In Bluetooth, small quantum of the time is called 1 tick. The tick duration is 312 microsecond. It's called 1 tick is the smallest this one in transmission duration. In case of Bluetooth, to tick, the time is 312.5 microseconds. You can see how small it is. Okay, intervals. 2 clock ticks make up a slot. You can see the lowest. For example, you say second, correct? 60 seconds, 1 minute. 60 minutes equal 1 hour. 24 hours equal 1 day. Like that. Here, in case of Bluetooth, the smallest time is called 312 microseconds. Okay. If 2 ticks are added, it is called as 1 slot. Right? That what automatically will double. Multiplied by 2 will become this one. 2 slots make up 1 slot pair. Right? Ticks slot pair. Okay, these are terminal you have to remember. And each simple case, in a simple case of single slot packets, data is sent as a slots. Actually, a packet can convey 1 slot duration. It can consume 1 slot duration. How much will be 1 slot? This much. Correct? Yes. In simple case, a single slot packet, the master transmits in even slots and receives in odd slots. We'll see that how it works, basic understanding. Right? So we know that in case of LIN bus, what is this? Master sends header, correct? Which contains the data number, all these things. Correct? Slave, remaining part of the frame, slave sends the data, master receives. Correct? We saw the LIN bus. Similar to that, in the master transmit in the even slot, this receives in the odd slot. Correct? So one transmits in the other for zero slot, master transmit, slot 1, the slave send the data. Then again 2 master sends, like that. Correct? We can say master odd even. The slave conversely receives in every even slots and transmit order. You can see that master is transmitting, slave and master also receives, and slave transmit, slave also receives. So, but they give in alternate slots. Start mid time frame. You will see that. Okay. In Bluetooth enabled device, when turned on, sends a signal called page. Correct? You have two. For example, you have cell phone, Bluetooth is available. No, correct? You have music system in your car. Correct? In cell phone, you have. If you want to connect with the car Bluetooth device, music system, what do you have to do? You will switch on your cell phone. In that, you enable the Bluetooth. Correct? Then you immediately what your device will do. No, your cell phone inside the Bluetooth device, it will try to send some data and look for whether any device is there nearby Bluetooth to respond back. Okay, so immediately in car, already music system is enabled. No, it will immediately say, "I am there." It will say. What happens in your cell phone? You see, for example, my car has this. I named my Bluetooth device of my Honda Amaze music system. That is the name I given. So immediately, if I enable my Bluetooth in my cell phone, it says that Honda Amaze Bluetooth is ready. Do you want to connect? Correct? That how it happens. When I switch on my Bluetooth in my cell phone sends a page. That's what we are talking. They call inquiry page. Correct? Sends a signal page. So my car Bluetooth device inside my music system, it recognizes this, immediately sends, "I am there," giving his ID. Okay? Using a special global ID, listens to responses to locate other Bluetooth devices that are active nearby. Correct? But because, for example, my daughter is sitting next to me in a car. She also has a Bluetooth. She enabled her Bluetooth. My music system Bluetooth also enabled it. When I switch on my car, my cell phone Bluetooth, it said there are two Bluetooth devices. Correct? Because it sends a page and asks whether anybody nearby Bluetooth. I will receive two Bluetooth devices. One is music system, other one my daughter's phone. I can select which one to connect. So that's what they call inquiry. When you switch on this one, immediately they talk with each other by sending some special information and says the regular. Correct? Active Bluetooth, you can perform page or inquiry for every 1.2 milliseconds. What happens when I switch on my cell phone and enable my Bluetooth? It's every 1.2 milliseconds, 1,200 milliseconds, my device will send a message to neighboring devices. They will respond, "I am there." My music system says neighboring. I accept or I decide, but my device will go on sending on each channel for 10 milliseconds before moving to next channel. It sends one channel. Music system, no response, it goes to next channel. Correct? Like that, it transmits. This continues. This is called inquiry scanning. So my cell phone device, Bluetooth will inquire neighboring device every 10 1.2 seconds once for this one. Now, once anything responds, it informs me. Right? If nearby there is no other Bluetooth device switched on, what will happen? You will never see nothing. In my cell phone, I switch it on. If I switch on my cell phone now, Bluetooth, it will say there no device there, but it will go on sending. Suddenly, somebody comes near me with a Bluetooth device connection. My cell phone says there's a device nearby. Do you want to connect? Right? That's what is happening. If Bluetooth device detects a page or inquiry, it will respond with frequency hopping packet. Correct. I switch on my cell phone, Bluetooth, it sends a message, page, the first is page information inquiry. So my car music system response, correct? What it responds? So immediately this will respond with frequency of a synchronized packet. That's how first packet will be sent. Okay. After scan is performed, inquiry Bluetooth, that is called master. My cell phone become a master. I am connected to my music system. That is a slave. Okay. We have list of FHS packets of all devices within the range. Shares. You can have multiple Bluetooth devices nearby. Right? About each device, there is a table. Right? That's what we are talking. Right? Bluetooth shares the FSL packets nearby devices. When a device joins a Pico node, it is assigned with a ID number, 3-bit ID number. Correct? Why 3-bit? Why not 4-bit or 2 bits? Any idea? It is similar to, for example, CAN bus. We have 11-bit ID.
The 7 devices.
Because only 7 devices are there.
Yeah, fantastic. Very good app. I am very, very happy. Because we said you can connect only 7 devices, including master 8. 8 means 2 power 3 is nothing but 8. Correct? So that's why it sends. Then a device get connected to one place, park mode. A device once connected, it can place in a park mode. Because for example, music system I can put in a park mode. Every time you need not connect. Every time try to connect, that means send a page, then receive, then send the FH this frame, that synchronize. Why waste? You can keep it parked mode means the device is connected to your cell phone. See, I can connect my daughter's cell phone and also my music system. One can be put in a park mode. Correct? Other one I can disconnect. Again, I can put another one in a park mode. I can do this one. That's what we are saying. Correct? So your device is connected to park mode, or the AMA free to use another device. That's what Piconet. We know the 7 device only connected. You want to connect the 8th device. That's the 8th device you want. You can connect, provided you make one device in park mode or disconnect. That's what you're saying. This is nothing but you need not disconnect. That device can be put in a park, but you can connect a new device as the 7th device, last slave. But at a time only 7 devices can be in active mode. Okay. A connection in Piconet between master and slave results in frequency hopping algorithm by the master. We'll see what it is. Just note down the important point. The connection is, please know the master and slave. That means master has a full command. Okay. Whenever master has, slave has to give data. Already we saw in case of LIN bus also. Slave, right? The master slave, this one already we saw. Hence, it is a distributor hops along the slaves with a space synchronization. It gives slaves equal time of opportunity connectivity. Correct? So, master inquires, slave provide data. Correct? So, in the sense, the Bluetooth is a packet-based protocol. I told you, data is transmitted as a packet. Where in case of this one, CAN bus already we have a frame. Here we call the packet. Packet size already fixed. The clock determines how the information is exchanged between the Piconet. Each packet of this one. Transmitted data is divided into packets. Each packet transmitted as 79 Bluetooth channels. We'll see what it is. As I told you, Bluetooth uses 850 megahertz total bandwidth. That is divided into 79 channels. Okay. At a time, you can transmit data in any one of the channel. Right? Each packet can be sent in any channel, whichever channel is available free. I will show you in the next slide, then you will understand. Note on the important point. Okay. So how the Piconet is formed? Piconet, basic unit Bluetooth network. So you can connect up to master plus 7. So this is one Piconet. Here you have 4 devices. Correct? In this second Piconet, you have only 2 devices. And this device, correct? So is common between 2 Piconets. Please note that you can have only 7 devices, but you want more than 7 devices in information from this one. In Bluetooth, how will you get? You can form 2 Piconets. In a net, here only 4, here only 2, but this device or node is common to both. That means data from this can go here and go like this. So totally how many devices connected? 6 devices. Here you can have another 4 more also, correct? So this will be 5, this is 4, totally 9. But you need 2 this one, and you can have a common this one. This is possible. Okay, basic unit is networking, master and sorry, this is one master up to 7 slaves. This is one master and 7 slaves possible in a Pico network. Master determines the channel and phase. Okay, which channel you going to do? I told you next slide I will show you the 850 megahertz bandwidth divided into 17 channels. Correct? In which channel the data is transmitted to slave is decided by the master. That's what I'm talking. Okay. Then other one is called scatter net. Device in one, so yeah, basic unit, that's what you explain. So this is one piconet, that's what we are talking. Then you have the second piconet, this is the second piconet. Now if I want to connect together, the whole thing is called a scatter network. Two networks scattered, but they are connected by a common device. So it become a bigger network. The limitation 7 is overcome by connecting two piconet, which is called scatter network. Okay. So Bluetooth communication system, we talk about the frequency hopping. Frequency hopping is the process of repeated changing the data frequency during the transmission. We'll tell what it is. Just take the point. Okay. A common form of frequency hopping involves spreading the original narrowband data over wide bandwidth than required for its transmission. Okay.
Sir, hello.
Great.
Yeah, just 5 minutes break, sir. We will come.
Definitely. Thank you. We will meet after 5 minutes.
Okay, sir. We will back at 6, 7.
Yeah, 6:10.
Okay, sir. Okay. Thank you.
Okay.
Sir, we can start, sir.
Okay, thank you.
Right.
So here the data is transmitted as a divided. Data is divided into small pieces and transmitted in different channels, because you know that there are 79 channels. Whichever channel is free, in that the data will be transmitted as a small packet. Okay. So so we are talking about this. It divides the signal to several channels of the low bandwidth in pseudo random phase, right? And by changing the frequency of the carrier. Okay. Then changing frequency in this way is called a frequency hopping. Hopping means, jumping, right? First I transmit this one. We'll go back to this one. It will be easy for you to understand. Yeah, you can see this picture. Frequency hopping time division. They call FHTD. Hopping means changing, and the time with respect to time. Please see here, the master is wanted to transmit something, and he transmit the data in a basic unit. What is this one basic unit? Any idea? Just now we talked.
Slot.
No. Thank you. Tick. Correct. One tick is 62.
Sir,
Yeah.
tick is half of
This is correct. Thank you. Sorry, I made a mistake. You are correct. This is one slot. If you divide this, one tick. This is 312.5 microsecond. You are correct. Thank you very much. Who is that?
Sir, Vikas here.
Vikas. Kind of you. Thank you. So in a slot, the one slot, master sends some information. Okay. The slave responded in the next slot. We know that 0, correct? 2, this is 1, 3. Master will always ask for this one, communicate only in the even slots, correct? 0 is even slot. This is 2. So slave responded in the odd slot, correct? We talked about that is shown here. Next one is, you can see the second figure. We know that with respect to time, this is a time increasing. This is divided into 79 slots. 79 channels. Frequency is 2400 megahertz. Is nothing but 2.4 gigahertz. And this is 480 highest, that is 2.48 gigahertz. So it is divided into 0 to 79 channels. You can see that each one is divided into the total. Now, what is frequency hopping means? What is you take this packet. Okay. This is one packet size shown here. Now, the first packet is transmitted at this frequency, correct? In this band, 78 channel, the frequency, center frequency 2.48 gigahertz. That is the carrier frequency, in which the first packet is transmitted at this one for one slot duration. Okay. Next, this one, this slot is not available. Our master decided to send the second packet in the channel number 77. You got it? So what is the frequency? Central carrier frequency 2.79. Though now this transmitted is then next 3 packets of data is transmitted in this channel number 1. Okay, then the next this one, what happens? Packet is transmitted at the channel number 76. Then you see the last slot, last packet. Actually, the master wanted to transmit, for example, totally 7 packets. Right? So it is not going to, it can transmit in same slot. That is same, same channel. Right? It is possible, but in the Bluetooth, they don't do it for many reasons. For security reason, Correct? You are changing frequency so that people cannot intercept what channel you are sending your data. That is one advantage. Right? That is one of the reasons for using frequency hopping, time division. They call multiplexing. Multiplexing means changing. First, you transmit in the channel number 78. Next slot, you change the frequency in the next channel. Then third one, next 3 packets in channel this. First channel. And fifth, that is 6th packet in the channel 76. Last packet in this. By you are going to transmit data in Bluetooth in different channels at, right, by having different frequencies. This is called a frequency hopping. Hopping means jumping. The data send is not in single frequency. In case of the other devices, for a radio communication, FM radio, 108 or 88, 92.4 Mirchi. You go and tune, always it will be only one channel, regular transmission. But in case of this Bluetooth, each packet is sent in one particular slot at different channels. And which channel should go is selected randomly, not random, pseudo randomly. What is pseudo? Partially. It's not true random. Why it is partial? Anybody can say after seeing this 7 packets, why it is not random, why it is called pseudo random?
Because everything is not falling. Nobody, no data is coinciding with any particular channel in that way.
That's okay. That is random, no? But why pseudo random? If you see this, how any idea? If you can think it. So you know that random is first packet this channel, second packet 77, 78, 77. Third packet came to channel number 1. Fourth packet, where it should be some other channel. Fifth packet should be some other. But in this case, you can see that all 3 packets, next 3 packets sent in same channel. You cannot say random.
Yeah.
Pseudo means partially. It is not random. You cannot say sequential also. Correct? So that's why it calls pseudo random. This algorithm is built in. Correct? So it selects randomly. Sometimes you can send 2 or 3 packets in the same channel also. That's why it is called as pseudo random. That if you say pure random, every packet should be different channel. No packet should be. You can repeat it, but not immediately consecutive. But correct. So they called pseudo random, partial random. Okay. This one thing, and then frequency. I just want to say here, I wanted to transmit one data. Correct. One data. The data length is this is 1 slot timing. Correct. In 1 slot, we know that how many bytes you can transmit. So, but it is big data. You see that orange color is one particular data wanted to transmit. One data. How many this one slot you require? 1, 2, 3, 4, 5, 6, 7, 8, 9. Total time needed is 9 slots. Such a big data. For each slot, you know how many, there is a very small amount only can transmit. But data was actually literally big one. What this Bluetooth is doing before transmission, it was generally transmitted 1 slot only. At a time, only 1 slot duration. 620, within that, so many bits of data. And in particular frequency. Now, I say that this is 0, 1, 2, 3, 4. Correct? 4th channel, first packet was transmitted, 1 slot duration. Because I divided into 9. Total was 9. I divided into this one. Next one, I randomly selected this channel. Correct? This is 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Okay, 22. There are many channels, but we are showing this. So, first packet of this message, that total is a big message. It is sent as a first packet was sent in 4th channel. Next channel, 14th channel. Correct? Then again on 10th channel. You can see here 10th channel. Again 16th channel. Again 6th channel. Again, on the 20th channel, this is 20th channel. Again, it is on 8th channel, on 11th channel, and 3rd channel. Second channel. So the total message will not be sent in one particular channel. It will first divided into one slot to just small by this one, and each will be they call a packet. Each packet will be sent in a different channel. Changing the data, sending the same message. First message will be divided into this one. For example, I can have another message. For example, select. I transmit here. Right? Next one, I transmit here. Third one, I transmit here. Right? Then, third one, I transmit here. This is fourth. So over. Right? This is the fifth message. How many packets? Yes, 1, 2, 3, 4. Correct? Total time needed was 4 slots. I divided into 4. First slot I transmitted channel 0. Second one channel 2. Third one in the 4th channel. Then last packet is in 18th. Randomly selected. Over. This message completed. Okay. But similar to that, you can see that each color is one message. Correct? 1, 2, 3. Link is nothing but I want to transmit this data. So each one is divided in this one, randomly selected. Correct? For blue one, you can see the randomly selected. They all go. You got it now? What the frequency hopping? Frequency hopping, time division multiplexing. Time division, for different time, I will select different channels. That's why I call frequency hopping, time division, FSTD. That is the technology used in Bluetooth to transmit your data wirelessly. Please note the wirelessly. Okay, now you understand. So you can take the information now you understand. So changing frequency way is called a FSHD, frequency spread spectrum. Okay, information data split into pieces of certain size and are then transmitted using frequency pattern, jumping from one channel to another. This is for security also advantage. This is advantage of Bluetooth. Your data is secure. They get only piece of data, no use. Correct? My name I'm asking M, first packet, A, second packet, third packet. So suppose somebody is able to tune and get the data wirelessly. Because wireless data, you can't stop it. It is spread. Even they get M later, they get I later, something. Not all is available. Because tuning all the method, but you are going to do channel send data. So this helps in avoiding data by listening by somebody else. One other advantage. Okay. Bluetooth is a RODE technology called a frequency hopping. Already we spread spectrum. Data is packets. Already told you data divided into packets and transmit each packet or any one of the channels. 79. Each channel bandwidth 1 megahertz only. Okay. So it usually performs 1600 hops per second, which is adaptive frequency. Most of the time per second 1200 hops, hopping with one channel to another. What is slot duration? Already we know 625 microseconds. That one slot duration, correct? So 1620 hops can be possible, maximum possible. Okay, it is a low energy, uses 2 megahertz the total bandwidth, which account of 40 channels. Correct. Then frequency hopping technology provides resistant to interference and multipath effects. Correct. Already told you. Provides for multiple access co-located devices through piconets. Already we discussed about this. So summary of the Bluetooth, no doubt. This consortium initially started by these companies, big names. You can say Ericsson, telecommunication, Intel IC manufacturer, IBM computer manufacturer, Nokia cell phone communication, Toshiba IC manufacturer, all those things. I started initially, now there are 30,000 companies registered some 4 years, 5 years before. Now we don't know, maybe 1 lakh also. Right? Every year growing very fast. Connection, main is a connection, the peripheral devices, including Bluetooth speakers are available, no? Correct? Headsets, joystick, loudspeaker, all this in Bluetooth wireless connections. Small devices, low cost device, medical devices, GSM, mobile phones, although you can connect mobile phone with music systems, all those things. What is the advantage? Correct. It works on 2.4 ISM bandwidth. Correct. It is a low range, low diameter, low power communication. So the maximum power only 1 watt. Very short distance, maybe 30 to 40 meters only it can work, not more than that. It is resistant to jamming. Is not, somebody cannot stop your transmission jamming, no, they're not possible. And because it uses frequency hopping selective spread method to transmit actual data into multiple packets and multiple channels up to 1000. This one coax a multiple packet pico nets up to 7 devices can be connected. And if you want more, but this one you can connect to 2 pico nets can be connected by a common device. Already we saw. Interoperability is possible. Protocol stacks, TCP, IP, all those things. These are product. Don't worry. Maximum range is generally 10 meter. Can be extended to 100 meter. Maximum 100. Most of the time it is 10 to 20 meter. Bluetooth. Very short range. But allowed is 100 meter. Taken important points. I will go to the next slide. So where it is used, data and voice points, real-time data transmission, replacement of cables, wires are eliminated, correct? The cost, initial, all these things, eliminate need for numerous cable attachments. If you have the wireless connection, it is a fixed static connection. They are called as a fixed or static connection. Both devices are connected. My landline telephone sitting next to me. I cannot take up beyond 1 feet. The wire length is only 1 feet or 2 per landline telephone. Right? So anything connected wireless, there's a limitation. Here, this a dynamic connection is possible. Correct? Already you know, as I move your cell phone, if I take my cell phone, it is connected next to tower automatically as I travel. Already we saw in the Zigbee also. Libium, they showed no, as the vehicle is moving, it get connected. Same thing. Any wireless vehicle can be automatically connected nearest router or device so that it can communicate. Low cost, the total cost, there's a $5 to $10. I'm talking only transmitter, Bluetooth transmitter hardware making is only $5 to $10. Right? So you can Bluetooth device. That's why Bluetooth can be installed in any device. Your cell phone Bluetooth is there. The cost for your cell phone company was $5 to $10. So the hardware I am talking, the chip Bluetooth transmitter you have to include in your cell phone. It is damn cheap, and you get millions of products. It is a HDAC connection, temporary. HDAC means temporary. As you move, it automatically get connected nearest router, all those things like that connected. Correct? Similar to that. Okay. Next one, last one. What we are going to do is Wi-Fi. Correct? Wi-Fi is another short-range communication used for autonomous vehicle. Wi-Fi is a wireless local area. Already you know the cell, all the computers, correct? In your room, it was a laptop, everything is connected Wi-Fi only. Right? Wi-Fi is used for even computer connection also. It provides internet access to limited range. The standard number is IEEE 802.11. Wi-Fi is a trademark of Wi-Fi Alliance. Why Wi-Fi? Correct? Wi-Fi Alliance, there's like a consortium. Zigbee consortium like that. This is the alliance which restrict use of term Wi-Fi certificate products successfully. Nobody else can use the name Wi-Fi. Already it is registered by this company, Wi-Fi Alliance, group of companies. Okay, Wi-Fi uses multiple parts of IEEE protocol. IEEE 802 is a protocol, wireless protocol, in which many of the what is the power, what is the frequency, like that, right? Protocols that it automatically uses, but it is 0.11 is the subdivision. This is seamless to work with internet, even Ethernet protocol used for, already we know Ethernet, correct? Then IEEE standard 800 has many variants. Wi-Fi has many variants. 802.11 bar A, bar B, bar Z. There are many variations. Wi-Fi is there are many subvariants. That's what A, B, C represents. Okay, that we have to find out. Wi-Fi is a star network connection. That means one hub will be there. You know that there's a hub, wireless hub. You know, correct? In my room, I have a wireless hub in which my laptop is connected, my cell phone is connected. another desktop connection, desktop with wireless connection, right? DP with wireless. All are connected to, this is a hub, wireless hub. This is connected to internet, correct? Wire, correct? These are wireless connection. So this is a star connection. That means one center hub through which many devices are connected. That is called star formation. Already we saw in the Bluetooth also, star and mesh connections. Correct? This is star formation. It's a star. And all nodes or devices are connected to it. Correct? Here there's no mesh connectivity. In Wi-Fi, it is always star connectivity. Okay? The star topology makes easy to add or remove devices. Correct? I am connected my cell phone, the laptop. If I switch it off, automatically this goes off. I connected my cell phone, it goes off. But it does not affect the other device which is connected. Right? I remove the device, that is advantage of star connection. It goes to a router. Router is connected. As long as router is on, any device can be removed without affecting other devices. But in case of mesh, what happened? I told you. You remember? Anyway, for the sake of completeness, I just want to here. Okay. Now, if this router failed, correct? Because this is an outlet. So these two devices cannot transmit GAN. But in this case, if this device is failed, no issue, remaining four correct devices can work. Whichever failed only affected. Suppose if this device is failed, these two are gone. Correct? Router failed. If any of the router failed, that's problem. But alternate is there. Correct? If this itself failed, if this itself is gone, instead of that, if this is okay, this has failed. Correct? What will happen? Data from here will come here instead of going directly like this. Instead of that, it will come here, come here, come here, and go there and go here. Take a longer path. Okay, you got it? Own authentication system, end user security, lot of security. I am just telling key points only. Don't worry. Just only this. What is the difference? High bandwidth. You know that in the Bluetooth, what is bandwidth? Each channel 1 megahertz.
1 megahertz.
One megahertz.
Here it is 2
1
megahertz.
megahertz.
Higher the bandwidth is better. Bandwidth is bigger, it is better. But number of channels accommodated will be less. In a given bandwidth, correct? If I have each channel has bigger bandwidth, number of channels will reduce. Correct? That's okay. Here this is optimized for high data. What is the transmission rate here? 800 megabits per second. He said, what is this? Very high speed. 800 megabits per second. Because using Wi-Fi, we are talking cell phone, video cameras. Cell phone switch on. I want to talk with you. Bandwidth is needed. That's why there 500 megabits bandwidth. And what is maximum range? Up to 30 to 100 meter range of the Wi-Fi device. Beyond that, it won't work. If you move far away from the router, correct? I have a router in my room, in the outside my building, outside my room. Correct? I'm sitting here, only is on 10 meter. If I go away from building, automatically my Wi-Fi disconnects. More than 100 meter, it won't work. It uses 700 milliwatts only, less than 1 watt. 700 milliwatts is generally. Zigbee consumes less than 100 milliwatts. That's why Zigbee is only 30 meter range. We saw that, correct? Maximum is 30 meter. Here up to go to 100 meter because it uses 700 milliwatts, which is much higher. Works only if signal is strong and very close to access point. Correct? If Wi-Fi signal is not strong, your cell phone won't work. Correct? Wi-Fi, if you use Wi-Fi, say all those things, you have to be close. That means within the 100 meter range, it has to be. That's what is clear. Okay, finally, we are trying to compare three systems what we talked in last 6 hours we talked. Correct? Wi-Fi and Zigbee and this one. So Zigbee is often regarded as the mini version of Wi-Fi. Right? Only thing range is very small. 30 meters. Here the Wi-Fi is 100 meters. That's why they generally, but please note that both are different. Okay. Keep some as main feature, range, power consumption apart. Both are almost a commonality. Of course, in the this one Wi-Fi, correct? Bandwidth is very high. 500 megabits per second. That is very important. Zigbee and Wi-Fi use similar application. That's why I'm trying to compare. See, I'm not in this table. I'm comparing Wi-Fi and Bluetooth. Sorry, Zigbee. Now, Bluetooth, I'm not talking. Please know that Bluetooth uses frequency hopping technology. Correct? These two doesn't use that. They transmit particular frequency. That's it. That's why mini version this one will have. So note on the important points in this. Wi-Fi standard, this one is there. There are several protocols, versions of Wi-Fi. And in case of Zigbee, it is only one IEEE standard, one version. Wi-Fi is known to work at 2.4 gigahertz and 5 gigahertz. Now recently they started even 5 gigahertz, new bandwidth they allotted. Standard is 2.4. Now they are allotted. If it is not sufficient, they are allotting more because more Wi-Fi devices, like bandwidth is not sufficient. They're trying to get the recent development. That's why I said recently they include 5 gigahertz bandwidth also. That means there are two bands, 2.4 gigahertz and this one. Okay. Again, they want to go to 600 gigahertz, very high frequency, ultra high. They are proposing to go another one version. Correct? Each channel has 0.3 or 0.6 or 2 megahertz per channel. In Wi-Fi, per channel, 0.3 or 0.6 or 2 megahertz. That is the band per channel I'm talking. Total bandwidth is big. That is this one. Okay. Zigbee restricted wireless personnel reaching only 100 meters. I think I made this one. I made this table while making. This should come here. This should go here. Sorry. See, Zigbee should come under this. Bluetooth will come here. In the Wi-Fi, the maximum bandwidth is 54 megabits. Okay. 11 megabits is generally in the version A. Already know version A, B, C. You can see A, B, G, like that. There are some 15, 20 version. Some versions are using 11 megabits. While A and C versions are using 54 megabits. Higher bandwidth, transmission rate. Wi-Fi is not a power efficient channel. Wi-Fi devices need a good battery because they consume little more power. Generally, most of the time they work only for 10 hours compared to Zigbee. Zigbee is a low power. Range is small. Why? Here it is up to 100 meters. Here it is only 30 meters. So we are using milliwatts, 100 milliwatts. Right here 100 milliwatts. Here it is 700 milliwatts. So battery cannot come for longer time. Wi-Fi devices. Correct? Zigbee device can work for longer because low power, short range. Shall I go to next slide? I think we have come to last slide. I think one or two slides today over. Tomorrow we talk about this one, path planning. Then it will be over.
Okay, sir. Can go.
Yeah. Okay. Yeah. Same thing only. Additionally, same table extend to next page also. The last slide, please take the notes. That's it. Regarding the exam, but timing already we fixed. Arnasalam?
Yes, sir. 10 to 1, sir.
10 to 1, correct? Because the optimization process, Shankar Krishnapalli asking me timing you wanted to.
Yes, 10 to 1, sir. We can proceed with the same timing, sir.
10 a.m. to 1 p.m.
Yes.
That is on the 7th, correct?
6th and 7th, both.
7th is for this one, optimization.
7th is optimization, 6th is our autonomous, sir.
6th is Introduction to autonomous vehicle. Okay, because Shankar Krishnan Pillai today morning asked me, so I want
Yes,
to know the timing under this one. So
Right.
just last time you come to MSB 358, mechanical
Okay.
science, MSB 35, same room where you wrote last exam.
Sir, regarding assignment, whether we have to bring the hard copy directly to you or we will send the soft copy in mail. Which one is
No,
preferred, sir?
hard copy you can bring it.
Okay, okay. Then no issue, sir.
Submit to doing exam itself. But don't
Right, sir.
delay. Otherwise you lose 10 marks. If you don't give it that day, you lose 10 marks.
No, no, sir. Everybody will already they have started everybody.
Okay.
So maybe they have to complete.
Yeah.
Okay.
Okay. I will close
Okay.
today. Thank you
you,
very
sir.
much.
Thank you very much, sir.
We'll see tomorrow, 5 o'clock. We'll finish tomorrow last 2 hours
Thank you, sir.
Thank you, sir.
Thank you.
for the
Thank
part
you.
planning. Thank
Good
you.
luck.
Thank you, sir. Thank you,
Yeah.
sir.
Thank you, sir.
Thank you,
Use
sir.
attendance without fail. That's the message.
Yes, sir.
Chat message.
Yes, sir. Thank you, sir.
Okay. Shall I close?
Yes, sir. We
Just a
can
minute.
close.
Yeah.
Sir, we can close now.
Okay.
Thank
See
you, sir.
tomorrow. Okay. See you tomorrow. Thank you.